Alright, in this video, I'm going to walk through this entire assignment step by step. The key idea for this whole page is recognizing which distribution to use. If it's geometric, then we're looking for the first success. If it's binomial, then number of successes in fixed trials is the key idea. So looking at question 1, M&Ms, feel free to pause and read it by yourself. So we know the P is equal to 0.3. We're told that 30% of the candies are speckled. So P is 0.3. Part A, we want the probability that the first speckled candy is the fourth one. This is geometric. So the formula is 1 minus P raised to the x minus 1 power times P. Therefore, plug in the values, 0.7 raised to the third power times 0.3 is equal to 0.1029. Or you can just use your calculator to type P parentheses x equal to 4. Looking for that value, get 0.1029. But don't forget to use geometric PDF for this. And part B, what's the probability that the first speckled one is the 10th one? Same idea, but now x is equal to 10. So 0.7 raised to the 9th power times 0.3 gives you 0.0121. You can also use geometric PDF to get this value. Part C, what's the probability that we'll find 2 speckled ones in a handful of 5 candies? Now we switch to binomial. We want exactly 2 speckled candies out of 5. So n is equal to 5, p is 0.3, x is equal to 2. Use binomial formula or calculator to get 0.3087. Part D, we want the probability that the first speckled candy comes before the 10th. That means we want probability of x less than 10 or the same thing as probability of x less than or equal to 9. This is geometric cumulative. The answer is 0.9596. Part E. Now we want probability of x greater than 5, so we use complement. 1 minus probability of x less than or equal to 5 gives you 0.1681. Part F. What's the probability that it takes more than 4 candies to get our first speckled one? So more than 4 candies, which means probability of x greater than 4. We use the complement 1 minus probability of x less than or equal to 4 gives us 0.2401. Part G. Now binomial again. 20 candies, probability 0.3, 1 exactly 6. So probability of x equal to 6 gives you 0.1916. Part H. More than 4. So probability of x greater than 4, same thing as 1 minus probability of x less than or equal to 4, gives you 0.7625. Part I, fewer than 4. So probability of x less than 4, same thing as probability of x less than or equal to 3, gives you 0.1071. Part J, at least 7. Probability of x greater than or equal to 7, same thing as 1 minus probability of x less than or equal to 6, gives you 0.3920. Part K, at most 10 out of 30. So probability of x less than or equal to 10 gives you 0.7304. Part L, expected value for binomial. So expected value is n times p. Therefore is 25 times 0.3 gives you 7.5. Remember there's a binomial, like the formula for binomial and geometric for expected value are different. So part M, standard deviation, square root of np times 1 minus p gives you 2.29. Part N, expected number until first success. Geometric mean is 1 over p, so plug in the values, 1 over 0.3 gives you 3.33. Part O, standard deviation for geometric. So square root of 1 minus p over p, square root of 0.7 over 0.3 gives you 2.79. Okay, moving on to question 2, the blood type. So the possibility, the p right here is 0.11. So part A, expected number until first success. You're going to use 1 over 0.11 gives you 9.09. That's the expected number for geometric. Part B, first success on 10th blood donor. So geometric formula is 0.89 raised to the 9th power times 0.11 equal to 0.0385. Or you can just use your calculator. Don't forget to switch to geometric PDF. Part C, exactly 2 out of 20. So we're going to use binomial using the calculator to get 0.2822. Part D, at least 2 out of 10. Use 1 minus probability of x less than or equal to 1. You're going to get 0.3028. Part E, the mean is 150 times 0.11 equal to 16.5. Since this is a binomial, the standard deviation is 150 times 0.11 times 0.89 equal to 3.83. Part F. Supervised by the low number of type B blood donors at the blood drive, the American Red Cross wonders if the 11% estimate was too high for your area. How many type B blood donors would it take to convince you that this estimate might be too high? Justify your answer. So we check when probability is very small. So probability of x less than or equal to 7 is 0.005. So if we observe 7 or fewer, that's unusually low. So about 7 people would make us question the 11% estimate. Okay, question 3. A fair coin is flipped 20 times. Part A. Exactly 15 tiles out of 20. This is a binomial, so you're going to go to your calculator, type binomial PDF, get 0.0148. Part B. At least 15. Use 1 minus probability of x less than or equal to 14 gives you 0.0207. Part C. First tail on 10th flip. This is a geometric, so use 0.5 raised to the 9th power times 0.5 equal to 0.00098. Or you can just use your calculator to switch to geometric PDF and get that. Part D, before 12th. So probability of x less than or equal to 11 gives you 0.9995. Part E, expected number of tails. You're going to use n times p, which is 20 times 0.5, gives you 10. Remember, this is a geometric. No, this is a binomial, sorry. Standard deviation, you're going to use 20 times 0.5 times 0.5 gives you 2.24. Part G, you're going to use expected flip, you're going to use geometric to find expected flips onto your first tail. So 1 over 0.5 gives you 2. And part H, standard deviation, you're going to use square root of 1 minus p divided by p gives you square root of 0.5 over 0.5, approximately 1.41. Okay, so that's it for this video, and I hope this practice gives you a general picture, a good idea about how to do the binomial and geometric calculations.